Okay, so I'm live, right? So just people over there in the lobby, just confirm me whether I'm live or not. Okay? Just quickly confirm me. Okay. Let me do one thing. First, let me check from my end whether I'm like perfectly audible as well as visible or not. So if you guys feel like, if you guys can hear the sound of the fan, okay, so just bear with me because I can't put it off because it's too hot over here. Okay, just bear with me. I'm sorry. If you want, I can like raise the voice a little bit, but I can't like put the fan. I'll let it speed. So I'll just start with the video real quick, okay? So yeah, everything's perfectly visible, everything is perfectly visible, right? So let's start it, okay? Just wait a minute, so I'll just put it on the Discord. Okay, I'll put it on Discord, okay? So let's start with the video. Is there any lag? Is there any lag from my side? Can you guys confirm me whether is there any lag or not? Okay, now I think it's fixed. Even if there was a lag, I think it's fixed, right? Okay, so the first question, sorry, first question states that you're given n discs and your task is to split them between two stands or towers such that the product of the numbers of discs in each tower is maximized. Formally, if the first tower contains discs and the second tower contains A discs and the second tower contains B discs, so you have to maximize the product of A into B. Okay, and A plus B is formally equal to N. So what will be given to us is basically we are given the value of N and we have to divide it into two parts, A and B, such that their products are maximized. Okay. Now since I know, like, if I could have directly told you the answer what it will be, but I usually don't give you proofs because I feel that people like who are watching my video, they are already having a little bit of knowledge about the proofs, but over here I'm going to give you a proof. Okay. Now since we have to maximize this A into B, which means we have to maximize A into N minus A, because A plus B is A plus B is N. So we can write B as N minus A, right? N minus A. So we have to maximize this. That is basically we have to maximize N into A minus A squared, right? Now how can we maximize this? So we have to find the value of A such that it is maximized, right? Right. So in order to maximize this whole thing, we can differentiate it, okay? We can differentiate it. So if we differentiate it, it becomes N minus A by 2, right? This becomes N minus A by 2. Now if we differentiate it again, okay, if we differentiate it again, it becomes minus half. Now remember one thing, so I made a mistake, so we are not differentiating on the basis of x, we are differentiating on the basis of A. Okay, this is on the basis of A. So now it is a minus half, and we know that if it is lesser than 0, so it's a maxima. So this thing is going to be a maxima, right? So the value of a will be n minus a by 2, right? N minus a by 2. N minus a by 2. Sorry, not the value of a. This is not about the value of a. Okay. So basically, I made a mistake. So basically, n minus a by 2 is equal to 0 if we are going to consider it as a maxima, right? We know this formula that is derived from basic knowledge about class 11 and 12, those things, okay, the derivation things, maxima minima, which states us that n is equal to a by 2, right? Oh, I made a mistake. I made a very big mistake. Okay. This 2 won't be there in the denominator. This will be in the numerator only. Okay. This won't be minus 2. It will be, this won't be minus half. It will be minus 2 only. Okay. I'm so sorry for the mistake. Okay. This is wrong. Okay. This is wrong. So it basically means that n minus 2a is equal to 0, right? Which states us that 2a is equal to n and a is equal to n by 2, right? So what will it be? B will be n minus n by 2. So basically what we have to print is n by 2, n by 2 into n minus n by 2. Okay, so let's go into the code. I haven't printed it like that, but you can print it like this also. Okay, so this is what you have to do. Okay, so if you submit it, you will see that it gets accepted. Okay, this thing gets accepted. So do you guys have any problem regarding this? People who have joined, I'll just ask you whether you guys have any problem regarding this till now. So I'm extremely sorry because there was some connection error. I don't know what the heck is wrong with my connection though, but now, yeah, it is perfect. It's successfully connected also. Okay, so I may not be able to read your comments though, but I will be reading it from the chats, like from my phone. Okay, so you don't need to worry about that. So that's the first question. Okay, so let's go to the next question. Maximum sum. You're given an array AR of integers where n is the length of the array. Your task is to find the maximum sum of two distinct numbers such that, like, for the distinct numbers the exit bit is not set and for one of them it is set. Okay, so if we take this example, let's say this example, I don't know how to take this. So I'll just write it. Okay, 5 159 20 12. 159 23 12 है ना. Now from this 159 23 12, so what are the, like, we have to find out the maximum number for which the exit bit is not set and the maximum number for which the exit bit is set. How can we find it out? So let's say if a number is having a present, like a binary presentation like this. Okay, now if I'm going to consider the third bit from the end, so I have to remove these two numbers. So basically I have to divide it by 2 to the power 3 minus 1. Okay, more formally 2 to the power x minus 1, and whatever comes, if I want to find the last digit of that, so I have to mod it with 2. Okay, now once I mod it with 2, I get the whole thing, right? Is that clear? Okay, so at this moment I think there are not much people over here. So anyways, can't help. So that's it. Okay, so basically, so 1 0 1 0 1 0. So this thing, so we can do this, we can perform this. Now for every performing, after performing every, like for every number, if I perform this operation, so the output will be either 0, sorry, it will be either 0, the outcome can be either 0 or 1, because we are, the modulus is with 2, so the outcome will be 0 or 1, right? Now if it is 0, then we can say that this number belongs to the unset bit part, and if it's 1, then we can say this number belongs to the set bit part. Now from all the set bit part I have to find the maximum, and from the unset bit part I also have to find the maximum, and then I have to add them together. Okay, then I have to add them together. So I think it will be better if I show you the code directly. Okay, now see, so this is the function n x and vector ar of I. Hey man, how are you? So basically for A is basically I'm going to consider the bits which are set, okay, and for B I'm going to consider the bits which are not set. So I have to, A is the maximum of the set bits at x, B is the maximum of the unset bit at x. Okay, now I have performed the operation for every element. I am dividing it by power of 2 to the power x minus 1 and putting a modulus of 2 over here, and then if it is coming to be set, then I am implementing in A, otherwise I am implementing in B. Okay, now if in the set of, I mean if we are dividing the whole array into two parts, and in either the unset bit or the set bit there may exist that there are no elements for which the exit bit is set, or maybe there is no element for which the exit bit is not set, right? Like if we see this example, so 1 1 1, so all the elements are same, so no matter what, either the elements will be like, all the elements will have the same bit, so basically it will be either set or not set. So we can't have some element for which it is set and some element for which it is not set. It is not possible for this case. So in that case we have to return -1, right? So basically if A is equal to -1, it means that A hasn't been modified only, or B hasn't been modified only, then we return -1, otherwise we return A plus B. So is this part clear with you guys? Shobhatra, is this part clear? I'm just assuming that Shobhatra just came, so yeah, I think you won't be knowing like what I was explaining. Okay, it's clear. That's good. Now let's get into the next question. Okay, get count, and this is the last question because I haven't done the fourth question. I have done it, like I was going through an editorial, but I haven't got the basic idea of the whole thing because I think that this question was a hard question. Okay, so I won't discuss that. I'll just explain till get count only. So you're given a tree rooted at node 1, where each node represents a city in an empire. The king wants to identify the pair of cities for constructing castles based on the size of the subtrees. Okay, a subtree rooted at city A contains exactly X cities, and the subtree rooted at city B contains exactly Y cities. Then only he is going to consider a valid pair A comma B. So we have to find out how many valid pairs are there. Okay, how many valid pairs are there? Now, if we look at this, okay, this thing. So I want to copy this tree only. Okay, I don't know whether I can copy it. Yeah, I can copy it. Okay. So I've copied this tree. Okay. So what we basically need to find is, we know the value of x is 2 and the value of y is 2. Okay. So we have to find out how many nodes are there for which the subtree of that starts from that specific node is having a size of x, and how many nodes which has a subtree of y. Okay. Now x was 3 and y was 2. So if we consider 1, so there are more than 3, right? There are more than 3 in the subtree. So we can't consider 1. Now if we consider 2, there are 1, 2, 3. So basically there are 3 subtrees. I mean 3 plus the 2 node 2. So there are 4, right? So there are 4 nodes in the subtree. We can't consider that also. If we consider 5, so 5 and 8. So that is like 2. Okay, so we have 2. So for this, in this category, we have an element 5. Okay. Now if I go for 3, so 3, 6 and 7, that is 3, right? So basically for this, we are having 3. Now if we consider 6, so that is also 2, okay? So you can also have 6. Now since you have to perform like the pairs only, so you can choose any one from here and any one from here. That is NC1 and MC1, right? What is NC1? NC1 is N only. And what is MC1? MC1 is M only. So basically we have to multiply the size of them. Okay, like how many elements over here and how many elements over here, we have to multiply them. So you can see that over here there was 1 element and over here it was 2 elements. So if you multiply it, it becomes 2, right? Now let's, like if you check at the question, the query, it was 2 only. Okay. Similarly for this node also we can do it. So over here now the value has changed. Okay. Anyways, leave it. Like leave it. You guys will understand it, right? I just put it a little bit down. Okay. So now I think it's okay. So if x is, so what was the value of x for this? X is 3 and y is 1, right? So if x is 3, so let me not even write it as x and y. Okay. So one is 3 and other is 1. Okay. So for 1, there are total 1, 2, 3, 4. So there are total 5, right? 4 plus 1, that is the root itself. So there are 5 nodes, so it's not possible. But if you consider 2, so that is 2, 4 and 5, right? So there are 3 elements, so 2 is a valid thing. But if you consider 4, there is 1. If you consider 5, there is 1. And if you consider 3, there is also 1. Okay? So that is what is the size of this 1 and what is the size of this 3. So if we multiply them, it becomes 3, right? It becomes 3. You can see the answer is 3, I guess. Yeah, answer is 3. Okay. Now how we are going to perform that? Okay, how we are going to perform that? Now it is a very simple logic of DFS. Okay, it is a very simple logic of DFS. Now if you want to find out, like anywhere you go, like in any platform, you'll get this code. Okay, you'll get this code. This is basically using the stack in spite of using the recursive function. Okay, you could have used the recursive function, because if I want to find out what is the size of this subtree, so this subtree will be 1 plus the subtree of this plus the subtree of this, right? So that is the subtree of all the nodes that are connected to it. So I am using a stack so that I just remove this thing from here. Okay, so that's the reason I am using a stack. So you can see that I am taking a stack for node and parent respectively, and initially the parent of the root is -1 because there is no parent for root. Okay, and we just continue doing it, like while if count of node is 0, make it 1. Okay, and we just do it like that only. So you don't need to get into this. I'll just like, what I'll do is I'll just paste the link. Can I paste the link here? Okay, I'll just share this with you. I'll just share with this. I'll just share this with you. Okay, you don't need to worry about that. The code. So now you can see what we do. We are taking an adjacency array, and then we are taking like a count array, which tells us that how many subtrees are there. I mean, what is the size of the subtree which starts from the specific node. Okay, and then for every edge we are pushing in the adjacency array so that we make it a tree. Now we perform DFS from the first node, and we keep on updating the count and adjacent. Okay, I mean not the adjacent, we just keep on updating the count only. Then we have like a equal to 0 and b equal to 0, which is how many nodes are there in group A and how many nodes are there in group B. Group A means that there are X number of nodes in the subtree, and group B means there are Y number of nodes in the subtree. Okay. Now basically, for if it is equal to X, we make A plus plus, and if it is equal to Y, we make B plus plus, and finally we multiply A and B. Okay. This is normal multiply only. I just did it because I thought that what if it's int only, right? So that's the reason I did it. But you don't need to worry much about that. You could have directly gone for this also. Okay, it would give the same answer only. So that's what we do. Is this clear? Is this clear with you guys? I can see that 2 people are watching this. So if anyone new is watching this, so I'll just leave this. Just subscribe my channel, okay? And just subscribe my channel and like this video. So is this part clear till now? Anyways, this was the last question that I will be discussing. So yeah, that's it. So if this part is not clear, then only I'll just explain it to you again. Otherwise, I'll end the video. I'm too tired today, man. I was solving the lead code, and I didn't even like. I knew that the last question of this GFG thing was hard enough, but I was too tired to solve it by myself. Okay, I have the code. I have a code. I got it from someone. Okay, so it's clear, right, Shobhadra? X minus 1. Okay, so it's clear, right, Shobhadra? If it's clear, I'll just end the video. Tired today. Crystals, okay. So yeah, that's it. That's it for today.